The title of this notes is Operations of Complex Numbers, and we're going to focus specifically on multiplication and division. So last class we saw that there were two ways to express a complex number. There's the rectangular form and the polar form. In these notes we're going to do the rectangular form, but I want you to save room because we are going to talk about the polar form in class. So the first operation we're going to talk about is multiplication. And again, we're only going to look at the the rectangular form. We're going to save the polar form for class. So in the rectangular form, you want to treat I like it's a variable, just like you would treat x. If you're going to multiply your binomials, you can use either your FOIL or your box method here. When you get I squared, you can switch that to -1, and then from there, you can simplify. I'm going to have an example at the end of the notes here. Again, save some room for polar form. We're going to do that one in class. For dividing your complex numbers, again, you're going to treat I like you would treat a radical. You're going to multiply both the numerator and the denominator by what's called the conjugate. The conjugate just means that you've changed the sign. Again, I squared is going to convert to -1, and from there you'll be able to simplify. We'll talk about how to divide complex numbers in polar form in class. So a few quick examples for you. So take a look at the first problem. We have 1 plus 2i times 6 plus 3i. So we're going to multiply these two numbers together. I'm going to use the box method, treating I like I would the variable x. So I'm multiplying here. 1 times 6. 2i times 6, treating I like x, is going to be 12i. 1 times 3i. And then lastly, 2i times 3i. That is 6i squared. But I squared is equivalent to -1. So that's actually equivalent to -6. And then you're going to add your like terms. These are the two real terms. 6 plus -6 is 0. And then here's the imaginary terms. 12i plus 3i is 15i. So the product there is 15i. Right, likewise in number 2, this time we're going to square it. That's the same thing as saying 4 plus I times 4 plus I. You can use the box method again. This time I'll show you how you would FOIL. So first, you multiply 4 by 4, then the outsides, 4 times I, then the insides, 4i, and then the outsides, which is I squared. I squared reverts to -1. I'm combining 4i and 4i to get 8i. And then I squared becomes -1. And then I can combine the real parts. So the product is 15 plus 8i. I could have used the box method. Whichever is more comfortable for you. You have a choice between box method and FOIL. So then we get to division. How are we going to divide 4 plus 3i divided by 2 minus 3i? We want to treat the I like a radical in that it's not allowed to stay in the denominator. So what we're going to do is we're going to multiply by a fancy form of 1 called the conjugate. The conjugate means that you're going to change the operator in the denominator. So the conjugate of the denominator is 2 plus 3i. Fancy form of 1 means we'll have that in both the numerator and the denominator. When you're multiplying fractions, you multiply straight across. So first I'm going to multiply the numerators. Again, you have a choice as to whether you like box or FOILing. I'll do one of each for you for your notes. So if I'm going to FOIL this one, I'm going to get 8 plus 12i plus 6i plus 9i squared. And remember that I squared flips to -1, so this is actually -9. 8 and -9 have a sum of -1. 12i and 6i have a sum of 18i. That's the numerator. Now I'm going to do the denominator. This one I'll use box method for those of you who prefer box method. So I'm multiplying. And here I have negative 9I squared in this last box. Remember that I squared is negative 1, so negative 9 times negative 1 is actually positive 9. Now I'm going to add my like terms. Notice that positive 6i and negative 6i cancel out. So I have 4 plus 9, which is 13. That's the whole point of the conjugate. The imaginary terms will cancel out so that you have no i's in the denominator. You only have a real number. So then our last step to simplify this is we just want to write the complex number as real plus imaginary. So it's going to be, the real part is negative 1/13, and the imaginary is 18/13. So that's the quotient. So bring that into class, and in class we're going to discover how to do this in polar form.